A graph is used to visualize or create an image of numbers or data. A bar graph is used when we compare different groups. A line graph is used when we are looking for trends, which is a direction something is changing. This can happen as something increases or decreases, such as a pattern over time. We performed an experiment to find the relationship between mass and force. We used marbles with different mass to push a cup and used the distance the cup moved as a measure of force. We did 3 trials of each mass and recorded our results on a data table. The average distances the cup moved will be graphed. Because we're looking for a trend as we increase the mass, we will use a line graph. For every graph, you should have 6 things. You should have a title, an x-axis label, an x-axis scale, a y-axis label, a y-axis scale, and of course, your data plots. For our graph, we're going to be using the data from our experiment about mass and force. For our title, we're going to list both our independent and dependent variables, just like we did on our data table. Now we've completed our graph title. Next, we need to have an x-axis label. The x-axis goes along the bottom of the graph. That is our x-axis. We need to label our x-axis. You will put your independent variable on the x-axis. Your independent variable is the one that you changed. In this case, we changed the mass of the marble by using different amounts of marbles. So here we're putting mass of marble, and the units we're using are marbles because we're changing the mass using 1 marble, 2 marble, or 3 marbles. Then we need to have our x-axis scale. The scale means what are the exact things within your mass are you using? We are using 1, 2, and 3. We'll start at 0, then we'll go to 1, then 2, then 3. Notice I have them evenly spaced on my x-axis scale. Now we have our x-axis scale. Now we need our y-axis scale. The y-axis is the vertical line at the edge of your graph. Our y-axis label is our dependent variable, which is the thing that we measured. In this case, we measured the distance the cup moved. So we're going to write that in. The units that we used is in centimeters. So we write that down on our y-axis label. Now we have labeled our y-axis. Now we need to have our y-axis scale. The way we figure out what numbers we need to put on the scale is we see what numbers need to be graphed. Our lowest number is a 5.6, and our highest number is a 22.4 out of the averages of each of our tests. So we need to have a scale that includes 5.6 and 22.4. So we need to start below 5.6 and end above 22.4. So if we look at our scale, if we start from 0, we could probably count by 2s, and we could get to 24, which would include our highest number. So we're going to go ahead and use 2s to count up our scale. Anytime you have a scale, you want to use up as much space as you can, but make sure that all your numbers are evenly spaced. Now that we have our y-axis scale, now we need to plot our data. These numbers on our data chart need to be on our graph somewhere. So what we need to do is we need to find with 1 marble, it moved the cup 5.6 centimeters. So with 1 marble, it moved the cup 5.6 centimeters. Now 5 is right in between 4 and 6. And 5.6 is about halfway between 5 and 6. So about right there is 5.6. How much for 2 marbles? Well, with 2 marbles, we moved the cup an average of 13.1. So with 2, 13 is halfway between 14 and 16, and 0.1 is just a little bit above that. So there is our 13.1. For 3 marbles, we move the cup an average of 22.4 centimeters. So we'll come up here, 22 right there, 22.4 will be about right there. Now, of course, since this is a line graph, we have to draw some lines. We're going to connect the dots. And that completes our line graph. We can now use this graph to draw conclusions about the relationship between mass and force.